Good morning, students. Today we are going to discuss SAHOO architecture. Already in cloud computing, we know that it has an advantage to store big and massive data. So here we are going to learn SAHOO architecture and why it is used. Since big data in the sense massive data, not only structured data but also unstructured data. Structured data means it goes in table, columns, whatever we maintain is structured data. And unstructured data means every documentation, any other things, files, images, videos, audios, everything. These all are unstructured data. So in the massive, when we need to store or process the massive data, we in the cloud computing, they follow the Hadoop architecture. So Hadoop architecture, we can say it's a Java based framework. So it is sponsored by Apache Software Foundation. So basically here we can see I have done the diagram for you. Like it has four components. The first one is MapReduce. It's also architecture which the cloud computing it follows so that the data can be read and processed. Then we can see it's HDFS. HDFS is Hadoop distributed file system. This is another component. Then YARN. YARN is yet another resource negotiated. It is a framework. What is this? Now common utilities. What common utilities is like Java library files and scripts. Already I have told that is an open source Apache framework. So Java library files and toolkits are given so that the whole processing can be done whenever data is processed. Then whenever any files or scripts, any toolkit is required, library files, then from the common utilities they take that processing. Now let me tell what is about MapReduce. What is MapReduce? Then we come to HDFS. And yet another resource negotiator is a framework. Resource negotiator means since we have massive data, so when it is the massive data is broken into small parts, and we say it as a job. So that jobs we need to schedule. We need to schedule, and according to the priority, they are being processed. So the work of YARN is to manage the resources. To process any data, whatever resources is required, whatever schedules, application are scheduled across the cluster is done by YARN. Then again, the smaller jobs, what is breakdown? Also, it manages user jobs and individual nodes. What the cluster? Cluster is a collection of nodes. Not only one node, cluster means have multiple nodes. So whatever data is there in multiple nodes, throughout the node, whatever job a user is processing, the managers user jobs on individually. In each node, if a user is processing the data, then that also is managed by the resource manager. Okay. So let me first tell you about the MapReduce. It is the first topmost part which a Hadoop architecture we require to process the data. So here I have drawn the diagram like what is a MapReduce architecture. So it has some certain components. The first component is the client. Why client? Because client is going to give the data, massive data or big data, what we say. So that massive data at one go, we are not able to process. So what the architecture it undergoes, whenever the client gives the jobs, then it is given to Hadoop map reduce master. Hadoop map reduce master. Now what is the work of this master? The work of this master, it also has a master slave. It follows the master slave technology. What is the master slave in the sense? Whenever the job is given to Hadoop map reduce master, what it will do? It will do the resource. It will break down into the job parts. The massive job is broken down into job parts. Then the resource, whatever it requires, will be managed by the master. The task what needed to be scheduled is done by the Hadoop master. Again, it will monitor the task. Whether the task is successfully processed or not. If it is failed, then again it has to be undergoing processing. So that all is monitored by the master, Hadoop master. And what the work of slave? Then whenever this task is broken down, job is broken down, then it is the job part is also known as task. Okay, the job part is also known as task. What according to the order of master, the slave is required to process each job according to the priority. According to the priority, but the tracking and monitoring of the task is done by master. And whatever task has to be processed is given to the slave, and the slave keeps whatever according to the priority which task has to be scheduled. The slave does this or executes this task. Then we can see here the input, whatever job inputs has given. Then we can see here multiple maps and reduce. What is this? Now, whenever a job is given to a map, then what it is done? It is broken into parts, right? So, if a massive data is processed one by one, it will be taking time. So here, what it is done? Number of maps have been done. Number of maps have been done. In number of nodes, number of maps have been done. What this map does? It follows the parallel execution. Parallel execution. At one go, after mapping, it will map the job parts in key value pair. So when the job pad is given to the map, then what it does? It converts into its intermediate key value. In the map phase, the job pad is converted to intermediate key value. So it will be a advantage. According to the key, we will group the same jobs. Then it will be given to the reduce phase. Now reduce phase what it does? It takes the value from with key value pair the group task. The group task is reduced to a group task, and then it is merged by the reduce phase. After it is merged, then it will give an output of the result. So from the map phase, what it does? The job parts is changed to intermediate key value pair, and those key value pair are grouped and given to the reduce phase so that the group task can be processed and aggregated and merged to give the result. So this all are done in a parallel execution. Again, how does we go for fault tolerance? I have already told that Hadoop map reduce master. What it does, if there is any task which is failed, then it will monitor the task and again it will reschedule and send it for execution. Okay. The slave, Hadoop slave, what it will do? It will execute the task. After the result is been done, the data, the file is stored in Hadoop distributed file system. After processing, the data is stored in Hadoop distributed file system. Since we are maintaining in a cloud, in a cluster, our data, so we have multiple name nodes, and slave node. So what the name node in the sense, it's a master node. In the Hadoop distributed file system also we are having master name node. What does it do? It keeps the data of the file system. Data, we can say metadata, data of the data. Whatever file after processing is given to Hadoop distributed file system, it has a name node master which will keep the data of that file system and regulates the client access to all those file system. and then it will give to the slave node or data node, which will then store the data blocks. If required, it will be deleted or replicated or means keep a copy of that data. So according to the advantage of cloud computing, we are having we can see a fault tolerance, scalability, data recovery and backup. And in the whole process, we are having our resource manager framework, yet another resource manager framework, and the library files which help in the programming aspects. Okay, so this is all about the hardware architecture and laboratory architecture, how to maintain the big data, how that is processed, and how it is stored in the distributed file system.